Scikit Learn, the newest band in town, have found a way to combine their passion for data science and music. To start their tour around the world and incite more people to join their data science musical quest, they have recently partnered up with no one else than the Lending Club to solve one of their most prominent issues nowadays.
Who is this Lending Club exactly? Well, Lending Club is a San Francisco-based fintech company who are offering peer-to-peer loans. It is the biggest lending platform it exists, and it is trying to connect people who are needing for funding with people who are willing to fund. As there are no banks involved, it is easy for the Lending Club to give their borrowers lower interest rates, which is a win-win situation for everyone.
Well, with such a big company and so many transaction costs, of course, there is an enormous amount of data. This valuable data has since their beginning been stored in their famously known datasets, the Lending Club datasets, which has been subject to many data science competitions in order to solve some important issues regarding loan offering.
But a little bit more about this band who is about to become world #1 on all top hit lists and is breaking all the records. The name of the Madrid-based band is Scikit Learn, and apparently this comes forth out of the fact that it is a free software machine learning library, one of their favorites, available in Python. But to know more about this, we asked our reporter to ask them why they specifically chose this name.
Well, this library, formerly known as Scikit Learn, features various classification, regression, and clustering algorithms, including support vector machines, random forest, but we'll go deeper into that stuff later on. So the library started out in 2007 on a Google Summer of Code project originated by David Cornepo. It is designed to incorporate with Python, numerical, and scientific libraries, such as NumPy and SciPy. As data science is not easy, this library was created to try to make doing machine learning in Python easier and more robust.
Especially for our viewers, we have a first view on their making of their new song, Lending Club, and the way they came about it. Enjoy! Let's see what they're up to. Hello?
Yeah, thank you, girls. So for you, our fans, it is very nice for us to always have a very nice video clip that gives the full understanding of our song, you know. And we also always attach the lyrics in form of notebook to understand for you what we are all about. So in this case, we had to do the business understanding of the Lending Club dataset, and that is why we had our binary classification problem. So this we understood from the data to classify someone as giving the money back, the loan, or the person as a thief, basically, that will not give us back the loan. So in order for us to be able to decide whether or not to give a loan to a future customer. After we had this business understanding and following the crisp DM approach with 6 steps, it was time for us to understand the data to be able to make this prediction. So what we first did in our data is check the dimensions, and this was an 800,000 rows with 74 variables available. We defined our target and clubbed our target into ones as don't give a loan and zeros as yes, we will give a loan. But in this target definition, we understood and we found out that we had an imbalance. So normally it's 50-50, but here we had 94% of loans not attributed. We checked the data types and we understood, of course, the variables where we were dealing with. So then it was the next step in our CRISP-DM approach to go over to the data preparation. In the data preparation, with this raw data that we understood, we wanted to transform it for the modeling. A first step to solve this imbalance that we saw before was undersampling. Undersampling is taking a sample of your majority class as large as your minority class, randomize it, so you have as many rows. Very important is that we take this sample only from the training set, we keep the test set untouched. We also tried oversampling, and oversampling is the other way around. From your minority class, you duplicate many rows, so you have as many rows as your majority class in the end. And here we end up with dimensions of over 1,500,000. And so the next step was dealing with NAs. A very important thing to avoid NAs in your dataset so you can have correct predictions. And we followed several approaches for this. You can set a certain threshold of rows having too many NAs, then deleting them. But when there's still a lot of rows that have NAs, so then you can also decide to delete these. You correct the data type for all variables, so for example factors are represent as categories, and we noticed that there were a lot of employees also, many employee types, same amount as IDs, so we decided to remove this non-explanatory column. Next up was feature engineering. As data scientists, it's very important to have the correct variables in your model to be able to make your correct prediction. With different opinions from different departments, you can have this full understanding of the problem. But besides creating the correct variables, it's also very important to make the correct selection and to not have too many variables. This can be done with wrapper and filter techniques, but also manually. So this then gives a better understanding of your model with the less variables, less overfitting. It is a faster way of modeling also. And finally, you can avoid the dimensionality curse with feature selection.
We can see there is a lot of work to be done. Especially the null values require some attention. As you can see here, there are 40 columns containing null values. We start by using a threshold for columns with more than 30% of NaNs. This leaves out half of the columns containing null values. The next step will be to look at the remaining variables and fill the NAs or drop rows containing them. Using this dataset without null values, every column is now assessed manually to make sure they are in the right format and usable for the modeling phase. For example, some columns will have to be deleted as they contain identical information than others.
Our prepared data, or our instruments, as you can say, we can start modeling our song. But for this binary classification problem, we would like to know from you, do you know some models that are well for using in a classification problem? No worries, we'll give you a little hint by drawing the outputs of 3 different models that we'll be discussing. This is the first model. The output of a second model might also ring a bell. And the third one is also quite famous. No worries if you still don't know it. The first one is the logistic regression. It uses a logistic function to give probability to the binary values of the target value, ranging from 0 to 1. It also uses the probability to allocate a default or no default based on a predefined threshold. Second up, we have the support vector machine. The support vector machine uses a non-probabilistic linear binary classifier and is also assigning new example to one or another class. And then finally, the random forest combines several decision trees, and by this combination, the habit of decision trees to overfit is solved. So these last 2 models especially have a lot of parameters to tune. It is different when a model, for example, has 5 different trees or has 20 different trees, or when a model goes deep to 20 different branches or only to 5. It will always give different outputs, but one or the other might be better. So in order to solve this quest, Superman will do hyperparameter tuning for us and will tell us with which outputs more important variables are prioritized than others and give us the best possible parameters for us.
First, and as a baseline, we started with the logistic regression. The logistic regression is a function that gives us a probability of the binary values belonging to the target value 1 or 0. So let's see how this baseline model performed. First, we got an accuracy score of, as you can see here, 88.1%. The support vector machine, also called SVM. The support vector machine is a great measure for binary classification as it analyzes all of the data points and kind of draws a line in a dimensional space between the different data points in order to best classify them. However, in our case, it was not very efficient in terms of computing time. The last model was the random forest classifier. So as a first accuracy result, we achieved some 88.7% in accuracy. However, using grid search, we could even improve the model further, as you will see down here. We were able to improve the accuracy to a full 89.4%.
We can have different models, but how will we evaluate them and see which model is the best one? Well, there exist a lot of different performance metrics. Can you think of some? The first one and the most known one is the confusion matrix, plotting the outputs into 4 different categories compared to the true and the actual predictions. We have then, of course, the true positives, the false positives, the true negatives, and the falsely predicted negatives. With these four, we can then again calculate a lot of different metrics. First one and most famous one is the accuracy, giving us all true predicted values versus the whole data set. We can then calculate precision and recall, one focusing more on false positives, other on false negatives, and specificity. And with recall and specificity, we plot the ROC curve, the orange line, and then the area under the curve is also a very good metric to see where our model stands. We have the MCC that gives us a good metric for an unbalanced data set, and our Formula 1, which is the F1 metric that really makes the balance between precision and recall, so when you don't know which one to take more into account. And then finally, we have cross-validation, not a metric, but a technique to help you validate the stability of your model and to understand how well the model handles new data. So it's also a good technique to avoid the risk of removing parts of your training data that can also deliver a lot of good information. Here you can see where we imported cross-validation. Model, a random forest with undersampled data set, grid search, and cross-validation. So we chose to evaluate it with the F1 score because we don't really know if the lending club wants to optimize recall or precision, but rather keeping it in a balance with the F1 score in the evaluation is then the safest option and also gives a grade score of 91%. When we deploy our predictions, we can go back to our business case and decide whether or not to give a loan to a future customer. So this crisp DM 6 steps are an iterative process, constantly evaluating and giving new insights to one or another to improve this final prediction. And we now have all the materials to make a great song.
Give me Scikit Learn for Python, solving all the problems, helping us to predict. Give me Scikit Learn for Python, machine learning is not easy, but with library it is.
This was the news with Jess and Camille.
See you tomorrow!